Hello, Gen Chemers. Here is a quick video about the mathematic description of light. Here we have two light waves drawn below. Light waves travel at a constant speed, the speed of light, 2.998 times 10 to the 8th meters per second. And there are two important variable values about light that you need to know. The first is the wavelength. This is given by the Greek letter lambda. The wavelength is the peak-to-peak length of the wave, usually given in meters. The other value is the frequency. This is expressed by the Greek letter nu. Frequency is given in units of hertz, where 1 hertz is 1 cycle per second. This is telling you how many times per second that wavelength is traveling past you at the speed of light. Let's look at a couple example problems. Example 1. Microwave ovens cook food by irradiating it with microwave light. If this light has a wavelength of 1.22 times 10 to the minus 1 meters, what is its frequency? We start by looking at our equation, nu equals c over lambda. We know c, the speed of light, because that's a constant, and we also know lambda because that was given to us in the problem. So we can just plug in our numbers. We've got 2.998 times 10 to the 8th divided by 1.22 times 10 to the minus 1, crunchity crunch, and we get a final answer of 2.45 times 10 to the 9th hertz. Let's take a look at one more example. While playing lacrosse, you suspect you break your wrist. You get taken to the hospital where they give you an X-ray. X-rays use electromagnetic radiation with a frequency of 7.522 times 10 to the 18th hertz. What is the wavelength of the X-rays? Looking at our equation again, we know the value of nu, which is 7.522 times 10 to the 18th hertz, and we know the value of c, the speed of light. To make our lives easier, we're first going to algebraically rearrange this equation so that we are solving for lambda. That is the variable we wish to know. So now our equation reads lambda equals c over nu. We can then plug in our numbers, and crunchity crunch, we get a final answer of 3.986 times 10 to the minus 11th meters. Now take note, these X-rays had a much higher frequency than the microwaves in the last problem, and therefore they also had a much shorter wavelength. I hope this cleared up a few things for you. I will see you guys on Wednesday.